Hi everybody, welcome back. We are about an hour and a half into our flight here from Heathrow to Vancouver. We're about 150 miles off the northwest coast of Scotland on our way heading eventually towards Iceland. Just got an alert in the on the flight deck that our fuel pressure in the center is low. That's to be expected. As I said, we burn off fuel from the center tanks first, and then move over to the left and right tanks. And you can actually see that on the synoptic display, how the thick green bar is going from the left pump to the left engine, and then from the right pump to the right engine, whereas from the main pumps, even though the right forward and after on, and the left forward and after on, the pressure from the center pumps is actually overwhelming the pressure from the left and right pumps, so the center pumps, or the center tank, is feeding our engines. That's primarily for weight and balance. You want to burn out the center tanks first. So now that we've received that message, it's a very simple procedure to remove it. Just go up to our fuel panel, and we turn our center pumps off. And that's all we have to do. From this point on, as I recall, there's essentially scavenge pumps that will drain whatever remaining fuel is there in the center into the left and right tanks, and then on into the engines. Not entirely sure these days what the procedure is on that. There's certainly nothing we can do from the flight deck, but there's concerns in the real world about fuel vapor remaining in the tanks. And that as the tanks get too low, they actually will expose some of the wiring that might be in the pumps themselves, and it has been known to cause explosions. Now is a good time to take a look at our progress. So as I said, we're 1 hour 24 minutes into our flight. We're on our way to 6015 north. That's about 118 nautical miles away. If you take a look at our progress page, if you were flying on VATSIM and they asked you to make a position report, this is actually how you would do it. You would take a look at progress. So we are on our way to 6015 north. We're estimating that at 11490, so just under 15 minutes from now. Our estimated fuel when we arrive there is 61,500 kilograms. I'm looking at my flight plan that I generated with PFPX, and it is actually estimating we should be at 61,000 kilograms when we arrive, so about 500 kilograms off. That's pretty good. That's pretty good. So we'll go back to our legs page, just take a look at our map just to see how we're doing on our course. I stepped away for a few moments, so it's a good idea to update our heading. And yeah, there we are. So we can see our next couple routes, or our next couple waypoints there. Now may not be a bad time to enter in a couple alternate airports as fixes, just in case. So a couple common ones that are used in the Atlantic are Shannon in Ireland and Keflavik in Iceland. So if we go to the fix page, Shannon is Echo India November November. Let's see if we can see it. It's actually out of range, but let's draw a ring around it. We travel roughly 500 miles an hour, so if we put a 500-mile ring around an airport, that'll give us an idea of where it is. There it is. You can see it down the lower left. So it'll give us a rough idea of where we can fly within an hour. On the fix page, you can put bearing and distance. So in our case, we're only interested in distance. You see the slash there. That means that if we enter a number right now, it'll be treated as bearing, but if we enter a slash first and then 500, that'll give us a 500-mile ring around Shannon. So you can see just when we pass 6015 north, we're going to be just about 500 miles from Shannon. This does not take into account wind as far as which one would be better to return to or to divert to, depending on our situation, but it's more for pilot awareness. I mentioned Keflavik is another airport that tends to get used as an alternate. That is Bravo India Kilo Foxtrot. And let's take this off the center and see if we can see it. There it is. You can see Keflavik there on our route. We're just going to do the same thing here. We'll do 500 miles. There you go. There you can see. So we're actually just sort of coming up on the point where they're about equidistant to each other. Right now, if I had to divert, I would probably, I would probably turn around. Because I've listed Shannon here as my closest airport, but that's probably not. There's probably some in Scotland that could accept us right now, maybe something like Stornoway or something like that. It would actually be closer. One of the things I'm paying attention to is the wind. So if we had a strong tailwind or a strong headwind, that might influence our decision as to where we'd want to divert to. If we had a strong tailwind right now, it would probably make sense to continue to Keflavik. On the other hand, if we had a very strong headwind, it might make sense to turn around and go for Shannon or something there in Scotland. So at any rate, just sort of a quick overview of some of the things you might want to think about during cruise. We have our fuel pumps, center fuel pumps off. And I'll come back and talk to you later on in the flight about some more of these systems, probably as we get closer to land. In the meantime, I'm going to do something that I absolutely love in the 777, and that is its time acceleration feature. It is so handy, especially compared to using the default time acceleration methods that are present and prepared. All you have to do is go down to your chronometer here and right-click on it. You can see that it turns green. That means it started in acceleration mode, and there it is. It's moved up to 2 times speed and now 4 times speed. And that's fantastic, because what it'll do is, as it gets to a point, now we're at 8 times speed, as it gets to a point where maybe it needs to turn, or it needs to adjust for turbulence or something like that, it'll automatically move back and forth between appropriate acceleration modes. So as we get closer here to 6015 north, which is, you can see it ticking down there, 55 miles away, 54, it'll actually drop down out of its acceleration to make the turn, and then once it gets back on course, we'll go ahead and move that acceleration up a bit. So it makes these long haul flights much more tolerable, where you don't have to sit in front of your computer the entire time. So I'll show you here how it's going to slow down as we make the turn, and then we'll come back later in the flight. Going at warp speed out there on the tail. Okay, so here we are coming up on 6015 north. And there you can see how we've already slowed down as we're making the turn. And again, that's just the acceleration slowing down, and then as soon as we're done making the turn, it'll speed back up. So we are just about, let's see, looking over at my display here, about 225 miles from the coast of Iceland. So again, catch up with you later in the flight. So we're just about 3 hours into our flight, and we're coming up on our step climb point. Let's take a look at our VNAV page and see where we are. So we're going to step climb up to flight level 360 at just about 70 nautical miles from now. In the meantime, probably be a good idea to reassess our potential alternates in case we need to divert. You can see that 500-mile line that we had set up for Keflavik, we're just about, let's see, 320, about 160, 170 miles away from it at this point. So let's go back to our fix page. Shannon, we're over 1,000 miles away from that. We don't need that one anymore, so we'll erase that fix. We're just coming up on the coast of Greenland, as you can see. So we should probably pick an alternate somewhere there. The best one that we can expect at this point is Kangerlussuaq, which is Sondre Stonfor, Greenland. So let's take a look at that one. Its identifier is Bravo Golf, Sierra Foxtrot. see that just appeared down there on our navigation display. And it's about 410 miles from us at a bearing of 107 degrees. Go ahead and put a 500-mile ring around that one, just to have it there as a reference. Beyond that, Fort Smith, Canada is probably going to be our next best bet. As we're just crossing into Greenland, it doesn't take that long to get across. It's what, about 500 miles across from the path we're going to be taking. So Fort Smith is Charlie Yankee Sierra Mike. And you can see it's almost 2,000 miles away from us right now. So we're not going to draw a ring around that one, but we're just going to sort of keep it as a reference. While we're waiting for our step climb, I figured what I'd do is I'd walk you through the flight plan that I put together in PFPX. And so let's take a look at that. So here's the flight plan. This is the first page of it. Air Canada Flight 855 from EG Echo Golf Lima Lima, that's Heathrow, to Charlie Yankee Victor Romeo, Vancouver. May 2nd, 2015. This is release number 1. We are in ship number Charlie Foxtrot India Uniform Victor. And here's our fuel planning. I talked about this, I think, in the first video. But our trip fuel and how long we expect that to take, our 5% reserve and how much fuel that gives us, fuel to our alternate, which takes about 13 minutes, a final reserve, as well as I added some contingency fuel just because doing a lot of talking on the ground or maybe later on demonstrating some like the heading select that I showed earlier, just stuff like that. Just figured it'd be good to have a little extra. So our minimum takeoff fuel was about 77,500 kilograms, with another 700 for taxi. Means that we were released from Heathrow with just over 78,000 kilograms, with an expected load remaining when we land in Vancouver of just under 11,000 kilograms. As far as our load planning, our empty weight was 168,000. We had 445 passengers plus 13 infants. For that weight there of 41,000 kilograms, you can see our zero fuel weight. On the right-hand side, you see our limits. So the maximum zero fuel weight for the 777-300 is 270,682 kilograms. There's the maximum fuel we could take on board. So you can see, even though we were relatively close to our zero fuel weight, we were way under on our allowable fuel load. Our ramp weight, that's how much we weigh when we're at the gate before takeoff. You can see it was about 287,000. Burned off about 700 kilograms on taxi out, so that put us at 286.5 for our takeoff weight. And you can see that the maximum allowed takeoff weight is 351,000 kilograms, so we were way under for that. Landing weight, we're expecting to be about 30,000 kilograms under. So you can see we are under load by 28,667, and that's limited by our maximum zero fuel weight. The next page here is our kind of route summary. So Air Canada flight plan, we're filed IFR, flight 855, there's again our ship number and our route, all our weights are in kilograms. Scheduled date of departure was May 2nd at 1700 Zulu. It's prepared by me. Again, ship number, and then the type of airplane, so Boeing 777-300ER with General Electric engines. We generated our route automatically, so we were planning to depart Heathrow from runway 9 right. That's at an elevation of 83 feet using a cost index of 50. We're going to arrive in Vancouver. You can see these are the ICAO codes and the IATA codes, the 4-letter and 3-letter codes. Planning runway 31, it's an elevation of 14 feet. Our initial cruise altitude, as we saw, was flight level 340. Our fuel bias, based off of how much fuel we actually burn versus how much is planned, we actually burn at about 103% rate, give or take. And then you can see our total great circle distance, so the most direct route between those two pairs was 4,097 nautical miles. Our actual flight plan distance with the various waypoints and departure and arrival procedures is 4,206 nautical miles. Total distance in the air, 4,175 nautical miles, with an average wind component throughout our flight of a tailwind of about 3 knots. Our alternate, as I mentioned, is Abbotsford, Charlie Yankee X-ray X-ray. There's its elevation and how far away it is from Vancouver. This is sort of a repeat of what we saw up above as far as our dry operating weight, our number of passengers, cargo, total weight, and how much we're under load by, as well as our maximum and planned, and then where there's a spot to fill in actual zero fuel weight, takeoff weight, and landing weight. Again, here's a recap of our fuel summary. Some notes on performance: that our fuel tank capacity is 147,851 kilograms. Based off of how much fuel we could load extra on this flight, we could load up to an extra 31,000 kilograms because that's limited by our landing weight, so we need to be below our maximum landing weight by the time we arrive, of course, in Vancouver. Our trip correction for 3,000 kilograms of takeoff weight increase, so let's say at the gate they loaded us with an extra 3,000 pounds of kilograms, or 3,000 kilograms of cargo, would increase our fuel burn by about 612 kilograms. Likewise, a 3,000 kilogram decrease in takeoff weight lowers our fuel burn by about 648 kilograms. Same thing here. If we were to fly 2,000 feet lower than our planned altitude, it adds about 4,700 kilograms of fuel burn. We have an estimated en route time of 9 hours and 18 minutes. We're expected to climb, as we said initially, at 250 knots, later on at 310 knots, then later on at Mach 0.84. And for the reverse there on the descent, 0.84, 310, and then 250. Here is where the flight crew would actually fill out some of their information. So here's our scheduled time of departure and estimated time of departure, scheduled time of arrival and estimated time of arrival, what time we left the block, what time we actually pushed back, what time we actually took off, what time we arrived, what time we landed. So we're estimating 2:03 so we can track what our actual landing time was. And then what time we blocked in at the gate in Vancouver, so that gives us a total block time and a total flight time. This right here is our air traffic control route. This is what we get transmitted to VATSIM. So we're going to be cruising at an initial 483 knots at flight level 340. We took the Buzza for Juliet departure to Buzzad, and then you can see the rest of our route: direct Delta Tango Yankee, Upper Lima 10 to Whiskey Alpha Lima, Upper November 864 to Bilbo, so on and so forth. As we're further along in our route, let's see, we are just 7040 north is our next waypoint, and at that point we're going to climb to a step climb of flight level 360, and so on and so forth throughout the route. You can see there's another step climb scheduled there at Gabbro up to flight level 380. And then our last official waypoint in our flight plan is Aliti, and then we're expecting the Whistler 3 arrival. Here's our alternate planning. So Abbotsford is our preferred alternate. So we would expect runway 25. It's 55 miles from Vancouver. We're expecting to fly at an altitude of 9,000 feet with a tailwind of about 2 knots. That'd take about 13 minutes to fly. Would burn about 1,800 kilograms of fuel, and then there's the route we would take from Vancouver. Similarly for Yankee Charlie Delta, I can't remember what the airport that is, but Yankee Juliet, that is Victoria. Bravo Lima India, that's Bellingham in the United States. The next pages here are our actual flight plan, so you can see the airway we're going to be on, the name of the waypoint, our magnetic track to get there, the altitude we're going to be at, how many miles that is, and how many miles to go, how much fuel we should have remaining and how much fuel we burned, and then how much time we expect it to that route to take, or that leg to take, and our actual time of the flight. So for instance, as we're coming up here on 7040 north, we're flying direct, so there's no airway that we're on. It's on a heading of track of about 335. We're expecting to be at flight level 340, and the temperature is estimated to be minus 61 degrees. The wind is estimated to be 213 at 049. I'm looking at it on the screen now. It's actually 229 at 9. Estimated, let's see, indicated airspeed, true airspeed. I'm trying to remember what these ones are here. I think these might be fuel burn. No, those are not fuel burn. Those are... So it's a 284-mile leg with about 2,600 miles remaining. This is how much fuel we should have left in the tanks and how much we burned so far. The latitude and longitude of those coordinates, it's about a 36-minute leg, and we should arrive there about 3 hours, 34 minutes into our flight. That goes on throughout the flight plan all the way into Vancouver. I also have wind information here for each stage of our route. So, for instance, at 7040 north, which is our next waypoint, there's the estimated winds, 215 at 44, 214 at 047, and temperatures, minus 62, minus 61, so on and so forth, at various flight levels. So if, for instance, we ran into a situation where our fuel was getting too cold, which I don't believe is simulated here in the PMDG 777, but I know there are other simulators that do it. We might have to climb or descend to a lower altitude to warm up that fuel. That's the official end of our flight plan. The rest of the information is just additional details. Again, this is our air traffic control flight plan, so this indicates our aircraft, 777 Whiskey, all the various equipment that's on board. We were estimated to depart London Heathrow at 5 p.m., 1700. There's our route, estimated to arrive in Vancouver at 8:53, alternate of Abbotsford, so on and so forth. The rest of the information is weather briefings. So as I was looking for alternate airports, Nanaimo, that was Charlie Yankee, Charlie Delta. That was the other alternate airport. So here's our origin, our destination, alternate airports for our arrival, adequate airports to divert to. So for instance, Keflavik was one of the ones we used earlier. We can see the weather report there. So this would have been a pretty good alternate. So at 2230 Zulu on May 3rd, the winds were 270 at 13 knots, visibility of 5,000 meters, light snow showers, few clouds at 1,100 feet, scattered 2,600, broken 4,800, temperature 0, dew point minus 0, QNH 1006. Then down here is the forecast. We were estimating that, or we left at 2230. The forecast at 1931, you can see, was winds 280 at 14. You can see the clouds there. Can expect some temporary reduced visibility to about 3,000 meters with some snow showers, and then it's going to be becoming winds out of the south, moving from winds to the east, becoming a little stronger, 140 at 25 knots, and then so on and so forth. And then here's the rest of the adequate airports along our route of flight. This here are just some maps of our route of flight. Let's rotate this here. Rotate. There we go. So you can see the wind vectors here. Each little tick there typically represents about I think it's 10 nautical miles. So taking off out of London, coming up over between Northern Ireland and Scotland, up over Iceland, into Greenland, and then there's a second half of the map that we'll look at momentarily. But you can see what we wanted to do on this route is we wanted to avoid, let's say, going further south, because you can see how strong those winds are, and those winds are going from west to east, and we don't want to fly into a headwind. We want to have a tailwind, or at least a crosswind, so we can go as fast as possible. So this is for flight level 320. We've got the same thing at flight level 360, flight level 400, and then here's the second half of the map. So basically the western half of it as we come out of Greenland, up across northern Canada, down through the Yukon Territory, and let's see, that would be Alberta up there, into British Columbia, and down to Vancouver. Again, you can see how strong the winds are over the United States. So by going further north, we avoid the strong winds, the strong headwinds that are down here, and then as we cross over probably towards Manitoba, something like that, we're going to get a really strong tailwind from north to south, so that should help improve our speed as we go along. So again, that's at flight level 320, flight level 360, flight level 400. So that is what something like PFPX gives you. Like I said, I'm a big fan of it. As we switch over here to the flight deck, coming up on 7040 north. Let's take a look at our VNAV page. And it's telling us that our maximum altitude now is flight level 362. Our optimum is flight level 351, and that we're going to step to flight level 360 now. So, easiest way to do this, go over to our altitude window, dial that up to 36,000 feet, press the button, and that resets our cruise altitude to flight level 360 and initiates thruster F VNAV speed. So when we leveled out, we were in, let's see, speed VNAV path. Now we're in thruster F VNAV speed. So what that means is we are, the auto throttle is commanding our reference thrust, basically our maximum thrust for this stage of our flight. So we're in climb mode, targeting 101.0% N1. So it's our reference thrust. And then the elevators are commanding a pitch to maintain about 290 knots from Mach 0.831. And we will take whatever rate of climb we can get. So you can see we're climbing at a rate of about 1,500 feet per minute, give or take. And just coming up on 1,000 to go. So I thought I would spend a few minutes here as we level off on our step climb, just sort of go through some of the synoptics in case you're not familiar with them. So we've already seen the engine display. So we've got the N1, which is our primary fan or first stage fan, our exhaust gas temperature. These are the kind of the primary engine instruments you use at all times. You can see our total fuel down there is just under 49,000 kilograms. Temperature is about -5. Our N2, which is the second stage turbine, is at 106.7% because we're climbing pedal pullback as we level out. You can see our fuel flow, 4,800 kilograms an hour in each engine. Our oil pressure, our oil temperature, oil quantity, 21 quarts in each engine, and vibration. And this just measures the most vibrating, essentially, component in the engine. It's not something you typically have to worry about, but if one of these starts getting out of whack, it can mean that maybe one of the engines is unbalanced or something like that, in which case you want to keep an eye on it in case you have to shut it down. We saw the stat page earlier. Not a lot to see here right now. You can see the quantity of each of our hydraulic systems. These were actually all below 1 when we started, and you can see that the center system actually is indicating a quantity of 1.15. That's due to some of the piping and ductwork that's in the hydraulic systems. There's actually reserve or stuff that's not in the reservoirs. It's actually in the system, so when we pressurize that, it starts flowing through the meters. But all those are within normal parameters, nothing to worry about. The APU, of course, is shut down, and the crew oxygen pressure is where we want it to be. Taking a look at the electrics, in the first or second video, I talked about how the electrical system is pretty impressive on the 777, and it tries to separate things into multiple sources of power as much as possible for redundant purposes. So the left generator from the left engine is powering the left main bus, left utility bus, left transfer bus. Similarly on the right side, and then there's backup generators as well. We can see our main battery volts and amps. Again, these are just for reference. You should not really use these for troubleshooting in case you have any sort of problems. You should really follow through the checklists. Hydraulics, we sort of talked about there. So you've got, again, 3,000 psi in each system. There's the quantities. You can see that the shutoff valve is open on the left engine. Through the left primary pump is where we're getting is powering the left system, which powers flight controls in the left reverser. Similarly, on the right-hand side, powers flight controls, the right reverser, and the normal brakes. Center system, you can see, actually divides into two. So you've got electric pump 1 driving nose gear and steering, as well as our alternate reserve brakes. Air system 2, or an electric system 2, drives the main gear and steering, as well as the flaps and some of our flight controls. And you can see there's isolation valves in here as well, that if there's failures can close some of these valves to make sure we maintain hydraulic pressure in the appropriate systems. As far as air, not a whole lot to see here for the time being, but bleed air is being provided by the engines into the packs, where we have a master temperature set of 24 degrees centigrade for the cabin, and then the aft and bulk cargo there are set at 7 degrees and targeting 12. All these different zones, A, B, C, D, E, F, those are zones that in the real plane the flight attendants can set temperatures for each of the zones depending on what the passengers want. I mentioned trim air at some point that smooths out the transition of the temperatures between these zones. You can see it's a little bit on the cold side right now. It's a little trim air indication right there. When we put up the pneumatic display here on the ICAS, we actually get some more information down here on the primary display. So we can see that our duct pressure is 50 and 51. Our cabin altitude, the altitude it feels like right now in the cabin, is 5,700 feet. Landing altitude is planned to be 0, and that's going to be automatically done. So the difference in pressure between the inside and the outside is about 8.6 psi. It's moving at a rate of 0 psi right now. And the valves, or the doors that regulate airflow, are mostly in a closed position. They're just slightly open. Doors, all of our doors are armed in automatic mode. Armed meaning if someone was to open them right now or we got on the ground, it would deploy the emergency slides. All of our gear is up, doors are closed. The inner numbers here are the air pressure in each of the tires. The outer number there is the temperature, and that's on a scale of 0 to 6, I believe. And the brake temperatures will actually continue to increase even after you're done braking. And it just has to do with their carbon fiber brakes that it uses. That as they are used, energy eventually continues to transfer into them and warm them up. Flight controls, we already checked that obviously earlier in the flight. If for some reason some of our hydraulic systems started to fail, and in fact let's turn one of them off right now. Let's turn off the left ones. So let's pull up the hydraulic page, and you can see the pressure starting to drop. And here comes our alerts on the ICAS. Let's take a look at flight controls now. So you can see, so first things first, silence the warning. Remember, aviate, navigate, communicate. So first things first is to be in command of your airplane at all times. This does not impact our autopilot at all, so we continue to fly like this. We can continue to our destination like this if we wanted to. But now you can see on the flight control page, we're still in our normal flight control mode, but the left side hydraulics are down, and you can see that it has caused these spoilers here to be disabled. One of the things I absolutely love about the 777 is the checklist functionality. So we were using our normal checklists earlier. You know, the pre-flight, before start, before takeoff, after takeoff, descent's going to be our next one. But it also includes all the various non-normal checklists as well. And you can see all the different areas we can look at. So for instance, we probably want to look at hydraulics right now. I think if we clear out of the checklists and then go back into it, yeah, you can see it automatically brings up the checklist for the appropriate items. And that's that little box there means, is that there's a checklist associated with it. So right now the messages we've received is hydraulic pressure system left is low. We have a message about our spoilers. We could not automatically land right now. And it says that there's status messages as well, so let's take a look at the status. So our flight control systems are degraded, no automatic landing. So if this was a four-wheel problem that we wanted to work through, we would start with the hydraulic pressure system left checklist. Condition: the left hydraulic system pressure is low. So, first steps we should take are the left electric demand pump selector to on. At that point, if the hydraulic system message blanks, we would hit yes, and it would tell us the various steps to proceed with. If it does not, it would tell us the appropriate steps to proceed with. You can see there's 2 pages to this checklist. So let's actually follow the checklist, see if we can get back to enrollment here. So, hydraulic press sys level left. Condition: left hydraulic system pressure is low. Left electric demand pump selector to on. So let's do that. Left demand to on. You can see that it's checked that electric pressure is on. Hydraulic pressure system left message blanks. It did. We have a different one now. We have hydraulic pressure primary left. We have a different message, so yes, it blanked. So yes. Our checklist is complete. We've done everything we need to do now for that checklist. We have a new item we'll have to do, which is hydraulic pressure primary left. Condition: the pump pressure is low. So, left engine primary pump switch to off, which we've already done. Note, the left thrust reverser may be inoperative. Okay. Just something to be aware of on landing. You can see that also canceled out our spoiler message as well, so that actually gives us enough to have our spoilers back, so if we look at our flight controls. Even though one of the pumps is down, we are still essentially in normal flight. So, it's a pretty amazing redundant aircraft. Go ahead and turn the pumps back to their normal position. And there all of our ICAS messages disappear. Okay. So we are 3 hours and 30 minutes into our flight. We finished passing it. We are just about in the center of Greenland right now. So I'll be talking to you again probably as we get close to our descent. And at that point we'll start talking about our plans for approach and landing. Thanks again. See you soon.